Hello, and welcome to a deep dive into AWS Cloud Map. I'm Alex Maros. I'm product manager with AWS Cloud Map. Today, we have Liam White, a software engineer from Tetrate, with us. Liam?
Yes, so I'm Liam White. I work on open source stuff, mostly for Tetrate, particularly Istio.
Amazing. So, today we're going to look into several aspects of service discovery in general. We're going to start with a quick introduction to that topic. Then we will look at the service registry for all your cloud resources. That's something that AWS Cloud Map provides you with. We'll look into rich discovery interface available with Cloud Map. We'll look at the ways of handling partial failures. And we'll quickly discuss integrations. And of course, we'll have a section on Istio Cloud Map Operator led by Liam. Liam will show his work and pretty much an integration between Istio and Cloud Map. Let's get started. So first things first, why we need service discovery, why it's so important today, for a number of reasons. First of all, modern applications are built with wide variety of resources, ranging from your workloads running in containers, to your cloud databases, to your storage services like S3 logs, maybe including some serverless components built with AWS Lambda and exposed on AWS API Gateway. So tons of different resources. Parts of this infrastructure is dynamic, so things come up and down. Sometimes your resources become unhealthy and they're being replaced dynamically. And it's very hard to tell which resources are available right now. More than that, with microservice architectures, the complexity of each individual component gets probably lower. The components become smaller. But with the growth of this number of components, the complexity of establishing connections between them grows dramatically. So in today's world, we also deal with multiple versions and stages that coexist and have to be managed simultaneously. All these different dimensions of complexity make it really hard to find out where to connect to for your applications. So service discovery is a simple solution to that. So it's just a process of finding the location of a service provider. You resolve your application name to maybe a couple of IP or IP port combinations, or maybe you can resolve your component name like my logs to a couple of S3 buckets. That's something that your applications really need at runtime. And of course, today these problems are solved in a couple of different ways. So with server-side service discovery pattern, we rely on load balancers that act as a proxy between client and service providers. Service providers register themselves with a load balancer, which acts like a service registry, and then client talks to load balancer. The load balancer takes care of all further communications. It's a simple solution. The discovery is completely abstracted away. All your client needs to know is that particular IP address of your load balancer. But it also introduces some latency, and in case of non-managed load balancers, it may also have availability and capacity impact. So there is another pattern that is quite common as well. It's called client-side service discovery pattern. And in that case, we don't have a load balancer in that picture. We still have a service registry, and service providers register themselves in that service registry. But client has to query the registry, figure out the location of a particular service provider, and then connect directly. So there is no load balancer, so we have fewer components in the system, but clients must be registry aware, and the load balancer should happen on the client side. So that's the thing that we With that, we're going to discuss today with AWS Cloud Map. AWS Cloud Map is pretty much that solution that enables service registry and service discovery and follows the client-side service discovery pattern. Well, in essence, Cloud Map allows you to build the dynamic map of your cloud. You can really define convenient names for all your cloud resources. That can be things like your ECS tasks, your EC2 instances, your EKS services. It can be things like S3 buckets, DynamoDB tables, SQS queues. Any kind of cloud resource can be registered and discovered using AWS Cloud Map. So you have a rich discovery interface that allows you to specify attributes on registration and then use these attributes to discover very specific instances of your services. Integrated health checks ensure that only health resources are discovered. And of course, we provide two ways of discovery, DNS and regional API. These are the things that I'm going to cover in that particular webinar. Let's take a look at the first of these important things, the registry for all cloud resources. And literally, it allows you to transform your application architecture that may look like that. You may have your front end running on EKS, back end running on ECS. You have some Lambda functions, some shared logs in S3. You also may have your payment processor working on EC2 instances and talks to a payments database on Amazon RDS. And all these things are named inconsistently, and some of these things can scale up and down. Other things are static. So you would have to configure the names for all these resources or use load balancers to communicate in that particular architecture. With AWS Cloud Map, you can transform it in convenient names that are all stored in one single registry. And your clients can easily query that registry or just use DNS resolution in some cases. And we're going to discuss how it works. To transform it into a convenient, unified naming schema. So you can have your namespaces like app.com with front-end, back-end payments DB, and also another like shared namespace for your event processor and logs. It's one of the examples that now available with AWS Cloud Map. Also, how it works. AWS Cloud Map service registry is comprised of 3 levels of hierarchy. On the top level, we have namespaces. Namespaces are groups of services that with common visibility and common discovery options. The services is the next level. Services are the most important things. You discover your services. And in our world, services are things that can run on multiple instances, common code that gives you the same, that executes the same common workload. And service instances are the actual resources that you run your workloads on. Things like your ECS tasks, or that can be your RDS databases. Let's take a look at different types of namespaces, because we do support 3 different ways of discovery, and that's really decided on the namespace level. So you need to understand how to choose the right type of namespace. The namespaces can support API calls only, then API calls and DNS queries and VPCs, and finally the third type is API calls and public DNS queries. The most important difference is in the type of supported resources. If you choose the namespace with API calls only, you can register absolutely any cloud resources that you want. If you choose to use DNS compatibility, so either in VPC or public, you will be limited to IP-based resources that can be registered in DNS. So if you have things like URLs or ARNs, you won't be able to register them and to discover them in these types of namespaces. In all three types of namespaces, you can use our Discovery API to find all the resources. And on the DNS level, if you choose the API call only namespace, you can't use DNS obviously, but if you choose DNS compatibility, it really depends. Either you can discover things inside your VPC, or you can make them discoverable publicly. One note: when you create a public DNS compatible namespace, you really have to delegate a domain name to corresponding hosted zone created for you in Route 53. So without it, the resolution wouldn't work on the DNS level. So an extra step is required. And when you create it in VPC, well, it's available pretty much immediately for name resolution. No extra steps. So pay attention to that. And speaking of DNS, it's also important to understand the difference between two routing policies that we support and we provide today. The first one is multi-value answer routing, and in that case, you can register your IPv4 or A records, IPv6 addresses, that's Quad A, or SRV records if you have IP and port combination. And on Discovery side, you get up to 8 healthy endpoints back. Let's say if you have 100 instances registered, each call would return you a different set of 8 healthy endpoints. And if you have only like 3 or 4, you would get these 3 or 4 endpoints shuffled every time. The second routing policy is weighted routing. It has more different record types. It supports more different record types like CNAME, or you can use alias for ELB. You get just one endpoint back, but you get more flexibility in terms of different record types that you may want to support. And real quick look at the APIs, how it looks and how it works. 3 steps. First one, you create your namespace. In that case, we create the namespace that supports API-only discovery. Provide a name. Then we create a service in that namespace, providing namespace ID that we get from step 1. And after that, we can register multiple instances against that service and provide a bunch of attributes. These are custom attributes. There is absolutely no schema. You can put pretty much any key values that you want. In that case, I decided to go with ARN, stage, let's say shard, read-only flag, and path. Now let's take a look at the actual console. Now we're looking at AWS Cloud Map console. And I already have 2 namespaces created in it. So the first one, cloudmapdemo.com, supports API calls and public DNS discovery. And the second one, shared, supports the API calls only. Inside that namespace, we have a list of services. And let's say here I have my payments processor, my backend and frontend services, and payments database. Let's take a look inside of it. We have a bunch of details related to service. We have a DNS configuration. In that particular service, I selected weighted routing, and I'm registering CNAMEs. Well, because it's my RDS database, I want to register my CNAME. And my TTL time to leave is 60 seconds. I don't have health check configured. And right now I have just one instance. Let's take a quick look at how I can configure my additional RDS database. Let's switch to another window and let's take a look at my RDS databases. Here I have my database with two instances, and right now I have only my writer registered in Cloud Map. Let's quickly register my reader. So I'm going to copy my, let's say, unique ID, and I want to start registering a new instance. So it's going to be a CNAME related thing. First things first, I need to provide a unique instance ID. It's going to be unique within that service. I can use my database. Okay. I can, in that case, I can use my database instance ID here. Then I want to specify my endpoint, and that's going to be my CNAME. Optionally, I can put a bunch of attributes that can be really important. So I want to use role, and it's my reader. So at the moment it's reader. Then I can register my ARN. I can add things like stage beta and maybe version 1.0, something that will help me later on discover it. And as well, I can add things like my configuration, and that will be, let's say, my parameter store configuration and my secret. And that can be now I'm registering my additional service instance, and now I have two instances registered with that service. We're going to take a look at how we discover them in a couple of minutes. Now let's switch back to the presentation and look at the discovery interface. So with AWS Cloud Map, you get really fast and secure name resolution via both API and DNS. You start with your regional discovery endpoint, and you basically call it with this providing a service name and your namespace name, and you get back the results, things that are registered in that service. You can use attributes for better discovery. All the calls are authenticated. And of course, you can use DNS-based discovery, basically DNS calls, DNS queries to get your names via DNS if you don't need any additional attributes. And attribute-based service discovery, that's quite powerful thing. You can register your instances with things like stage beta and version 1.0, exactly what I did a couple of minutes ago. And on discovery, you can provide these attributes and say, discover things that run in a particular stage that belong to a particular version. You can specify things like deployment IDs and many other dimensions of discovery that can be of interest to you. And this is quite useful things when you deal with incremental deployments and with smart traffic routing. What you can do with service attributes? Well, you can use all of them for discovery. You can have up to 30 different attributes registered. These are key value pairs, string-to-string mapping, with the key length up to 255 characters, and the maximum attribute value length up to 1024 characters. we have enough flexibility to build a rather complicated discovery system with all these things together. And that's a typical discovery query. In that case, I'm discovering my front-end service, and I can provide my query parameters. In that case, I want to get things that are ready to connect to, and I'm getting, let's say, one service. I'm getting back my IP, getting back my version, my stage, and that instance is ready. I get that flag. Now let's take a look at the actual Discovery API experience. All right. So now let's take a look at our payments database. We had just one instance. We registered another one, and we still have the same CNAME available with that endpoint. Now let's take a look at what we get when we use the Discovery API. We get two instances. One of them is writer, and the second one is reader. We also have a bunch of other information. We get the CNAMEs, different CNAMEs, different, they can have different configurations. We get ARNs associated with these guys. In that case, I actually registered availability zone. But now let's do a more detailed, more focused search and discover an instance that is, at the moment, writer. We get just one instance back, the instance that is writer. So my application can figure out which instance to connect to write to that database. Additionally, I can look up things like configuration, and maybe that configuration is stored in my parameter store, systems manager parameter store. I can use that command to get configuration and connect to my database instance immediately. So it's quite flexible. You can put up to 30 different attributes that represent different notions, different ideas, and do quite interesting things with your Discovery API. You can discover specific instances, filter down the result sets. Additionally, when you work with ECS or any other compute resources that have a lot of instances that may run in different AZs, you can actually build systems with smart routing that really help you route to the correct AZ. Right now I have just two ECS tasks running. Let me update my service. And with ECS, we have a really nice integration. I'm looking at my Fargate cluster with the service, and it has service discovery enabled. And it's mapped to my Cloud Map demo public namespace. So, and right now it has two running tasks. I want to update it, and let's say set the number of tasks to 4. Let me finish that process and update service. In a couple of seconds, ECS will add 2 additional task instances. And these task instances will be made available in Cloud Map for discovery. Now let's take a look at our discovery interface. And now we have 4 tasks that are automatically registered in Cloud Map, and they run in different availability zones. So what we can do, we can actually route traffic to a specific AZ. So we can discover things that run in a particular AZ. If I use US West 2A, I get just 2. Or I can pick 2 other tasks that run in US West 2B. So that's a quite useful mechanism that helps you with smart traffic routing. Switching back to the presentation. The next topic I would like to discuss today is how we handle partial failure with help of AWS Cloud Map. When you create your service, you have a way to provision Amazon Route 3 health checks for all your IP-based resources. Please note it works for IP-based resources only. In that case, all the unhealthy resources are removed from query responses automatically. You have an API to check the health status, and that all helps you build more resilient applications. So we don't remove unhealthy things. We keep them in the registry. They're just not visible to your applications. And if you have a way to find out which resources are actually unhealthy at this very moment. So it works in a very simple way with health checks enabled. They're constantly health checking your, let's say these are ECS tasks. And if everything is fine, your Discover Instances API returns healthy IPs right away. But let's say one of them becomes unhealthy, your next call returns only the healthy IP. There is another important feature of AWS Cloud Map I wanted to talk about today. It's custom health checks. This is a mechanism that helps you control traffic and really start or stop traffic routing to particular resources. So when you create a new service, you can create custom health checks with it. And in that case, you have access to an API called Update Instance Custom Health Check status that really sets the status to healthy or unhealthy. So you can say that instance is not healthy yet, don't route traffic to it. A way to retrieve your unhealthy endpoints. It's the same Discover Instances API call. We provide the same namespace name, service name, and additional flag, health status unhealthy. In that case, you get back just the unhealthy instances. Let's take a look at different types of health checks. So we have standard Route 53 health checks and custom health checks that you pretty much control. They don't do any active health checking. It's totally in your control. When you create an API calls only namespace, you get the support for IP-based resources with Route 53 health checks, and you always have you always can create custom health checks. In VPCs, unfortunately, Route 53 does not support health checking, so you have only one option, custom health checks. And when you do DNS queries, it's fully supported for all IP-based resources, for standard Amazon Route 53 health checking, and for custom health checking. Now let's take a look at integrations. Cloud Map is currently integrated with Amazon ECS, Amazon EKS, and the support for AWS App Mesh is coming. With ECS, when you enable service discovery, you pretty much don't need to do anything else. All ECS tasks are registered in Cloud Map automatically. You can discover them either via DNS or via API calls, And ECS actually provides 8 additional attributes with every task, such as availability zone, region, your ECS service name, cluster name, EC2 instance ID, and ECS task definition family. That helps you do that smart routing that I demoed a few minutes ago. And that is all available to you by default. ECS Service Discovery is supported for both EC2 and Fargate launch types, and well, it's available right now. Now I would like to invite Liam to talk about the Istio Cloud Map operator that actually helps bridge the gap between EKS and, let's say, Istio and ECS.
So, like Alex said, my name is Liam. I work for a company called Tetrate. We're basically extending and building on top of Service Mesh to help enterprise gain the benefits of Service Mesh. We're particularly working with Istio and Envoy. And as part of that extension, we've built an open source cloud map operator. It syncs information about your external services with Istio, using information obviously from Cloud Map. So I'm quickly going to go over a summary of what Service Mesh is. The general concepts are kind of the same with all Service Meshes, but the feature set I'm discussing here is mostly Istio's. So a Service Mesh is basically an abstraction on top of your application's networking, much like how something like Kubernetes provides container orchestration abstraction via an API. Istio is aiming to do the same for networking. Now, this abstraction is designed to enable the following features to be configurable via APIs. Traffic control, so things like A/B testing, circuit breaking, retries, rewrites, that type of thing. Traffic observability, particularly having consistent and detailed metrics across multiple teams, potentially working within the same kube cluster or across multiple kube clusters. Secure communication, so easy MTLS, TLS everywhere with rotated certificates. And policy enforcement, because the proxies all have layer 7 visibility, you can enforce policy on layer 7, so HTTP header concepts, that type of thing. And the idea is that the Service Mesh provides consistent experience of managing all these features by moving the logic out of the application code itself, so out of your client code in your microservices and into the platform itself. So the way it does this is it transparently intercepts traffic between services. So here, Service A is making a request to Service B. The Envoy proxy next to Service A intercepts the request, forwards the request on to Service B's proxy, and forwards it on, which then forwards it on to Service B. Now, this is an example of a purely, it could be anywhere, but this one particularly is Kubernetes, where the proxy and the service are running within the same pod. It uses something called the sidecar model. Now, the key thing here is that neither Service A or B is actually aware that there are proxies in between them. As far as they're concerned, they're talking directly to each other. Because we have this transparent proxy at each hop, it enables us to get consistent defaults across multiple teams, particularly for things like metrics. Envoy has a specific set of metrics that it exposes. So if you're a platform team running a service mesh, you might have multiple development teams, and by default they'll all have the same metrics and names, and you won't have to worry about matching it all later or enforcing certain standards on them. Because as well it's there by default, it allows for easy onboarding for development teams. It's language agnostic because Envoy itself is essentially an L3, L4 proxy, but it has awareness into L7. So as long as you're speaking a network protocol it understands, it is completely language agnostic. So you don't have to rewrite all this behavior for different languages, for different teams. It just deals with network protocols. Has a consistent set of observability data, like I mentioned above. It decouples network configuration from application code. So if you want to update the amount of retries on a particular microservice, you don't actually need to redeploy any application code or change environment variables on there. It's an interaction with an API. It comes with built in basically PKI for MTLS. It'll do your certificate rotation for you. Your development teams don't have to care about HTTPS as far as they're concerned. They're speaking HTTP to everyone. They don't have to worry about certificate rotation, anything like that. And because finally we have an envoy at each hop, it enables explicit policy enforcement points for you to enforce policy however you like. So now on to some of the Cloud Map stuff. So when you're communicating with services outside of your cluster, Istio needs to know information about these external services. The reason for that is it needs to program the proxy in order to go and get these, to go and communicate with these services. So in this case, and in the demo you're now about to see, we're going from an EKS cluster, well, a Kubernetes cluster essentially. It could be an EKS cluster. You could be running COPS on EC2 instances. It's up to you, but we're going from a Kubernetes cluster to something hosted in ECS or Fargate. Now, we need to know how to get to that, where those ECS instances actually are. And to do that in Istio, you would declare something like this. This is a service entry. It tells Istio about any external services that you need to go and talk to. Now, it's it'd be quite painful to write all of this manually, but luckily, we don't actually need to, because with Cloud Map, service discovery, so we have all of the information necessary actually to generate a service entry from Istio Cloud Map information. And that's basically what the Cloud Map operator does. It polls Cloud Map for information about external services, and then will also generate service entries for Istio to consume. So this looks an awful lot like the previous slide with EKS and ECS. Basically, this is what's actually going to happen in the demo. We're going to make a call into the Echo server, which will then forward on to another Echo server running in ECS, and that will respond with a 200, hopefully. So here we're making a request. We're using the HTTP plugin, but it's essentially like curl. It successfully made a request to our first Echo server running in EKS, and you can see here basically that Echo server has failed to talk to the other Echo server running in ECS. So now we're going to deploy the Cloud Map operator, and it is going to go ahead and create service entries for us. So if we go and look at the service entries, we should now see a couple in there. And these are just stuff that I have running in Cloud Map. This one here in particular is one of interest. That's where our ECS instance is actually running, or the IP that it's sat behind. So if we go and have a look at that, the Cloud Map operator here has manually populated, or automatically, sorry, populated the IP addresses in the service entry. It's also told it that the ECS instance is expecting requests on either an HTTP request on port 80 or HTTPS on 443. So now if we make that same request we made before, we should be able to successfully make requests through. And we've got the initial 200 from the local or the ECS or EKS even, too many acronyms, EKS Echo server, and then the response we've got from the downstream Echo server is a 200 OK, because the IP address is now in there, so it's able to go ahead and finish that request. So that's what we have for the demo. Currently, we support IPv4 services registered in Cloud Map. We're interested to see various use cases and how people would be planning on using this. So if anyone has requests for things like S3, DynamoDB, via CNAME, that type of thing, we can support things like IPv6, or even with Cloud Map, it can be, you can register your on-prem service, external services in Cloud Map, and then you can go and call into Cloud Map to register those. So we're interested in seeing some of the use cases to know, to kind of direct where we want to go with the project in the future. The repos here, please feel free to reach out to us or raise an issue, or even submit PR if you want to contribute the functionality. in there.
Thank you, Liam. That's a quite impressive demo, and thanks so much for joining us today. I do believe that now we can take questions.